right, so we're going to calculate the correlation coefficient for this fiber intake and low density lipoprotein example. We're going to do this by basically completing the missing sum of squares. When we created the regression equation, we already had the sum of squares for xy and the sum of squares for the x term. Now we're going to do it for the y term. To do that, though, I will need to square all the values in the y column. So I'm going to basically create a column here called y times y, or y squared in other words. I'm going to take each value in this LDL column and multiply it by itself. I'm just going to do it actually for one cell, and then I'll click and drag for all the others. And now that's basically done the work of squaring all the y values. If I drag this sum over, I will have the sum now of y squared. So for the sum of squares for the y, the formula is this term, the sum of the y squareds. So I'm going to say this value minus the sum of the y column, which is 2,975, times itself, or squared. And then you divide by how many values you had. Remember, we had 25 values here. Okay, so this is my sum of squares for the y. To do the r calculation, then it's really nice and easy. We have to, in order to calculate r, I'll just put it right here. I'll say r, and then it's going to be equal to, it's always the mixed term sum of squares, SSXY, divided by the square root. And in the formula here, I'll just start typing square root, so SQ, and then right away you'll see the first one comes out, square root. And in this little parenthesis, I'll put square root of, and it's the other two sum of squares multiplied here. So it's the sum of square for the x term times the sum of square for the y term. I'll close that up, press enter, and there is my r. Now, once I have that r, which is like negative 0.810, if I round off to 3 decimal places, I can check to see if it's significant. So let's highlight that quickly so we remember our value. And then we want to see how to check if it's significant. The way to do this is to use a special table called, okay, so I've opened up the table, and we're using this table because we're assuming at this point in the course you haven't learned how to test hypothesis in a formal way. So we're going to skip that for now. At the end of the course, you should have learned how to do that, and you can go back and do it in a different way. Or if you take a second stats course, you'll certainly learn to do it using a significance test. But here we're going to do essentially the same thing. But the way we're going to do it is use this special table where we're going to look up the sample size for the problem that we have. In our case, it's 25. So here's 25. And then we're going to look at the critical value. We're just going to use this first column that says alpha equals 0.05. Again, without the background of significance hypothesis testing, you don't know what that means, but it's okay. We don't need to worry about that. We just need to know that this number that's in this position where n is 25 tells us the value that we have to exceed. So if our correlation coefficient is larger than this number, at least its absolute value is, I should say. So if its absolute value is larger than this number here, then we're going to say our correlation is significant. So let's go and look to see what our number was again. Remember, it was, if you take the absolute value, 0.810, or in other words, 0.810, and that number is certainly bigger than the number in the table, which is only about 0.40, right, or 0.396. So because the absolute value of our correlation coefficient is larger than this number, we're going to assume that the regression is significant, or in other words, we can safely use the linear regression equation. It should probably be useful then. We're going to say that this guy is greater than the critical value, and that critical value that we found in the table, just a reminder, was 0.396. And because of that, we're going to say that it was significant. Okay, and that's all there is to it. So basically, you're looking for the absolute value of r to be bigger than the number you find in the table. If it is, then you can safely use this regression equation